Testing, testing. MATH0092, we're looking at Chapter 7, Section 3 only. Your test will include only Section 3 and any additional information that I might present in the lectures. We're studying data and statistics, and we're focusing on page 429 through 434. We begin the chapter with looking at a graph. Now, graphs are a very usual way of displaying data in order for us to visually see and be able to make comparisons. So in this traffic chart, we have traffic congestion delays. We're looking at each year that we collected data, and we're going to plot the average annual commuter delay in hours. Traffic congestion in the United States in 2014 cost commuters $160 billion, wasted 3.1 billion gallons of fuel, and resulted in 6.9 billion hours of delay, or 42 hours of delay per auto commuter. Those numbers are astounding and have only grown since. The average commuter delay nearly doubled from 1986 to 2014, almost doubled. So it went up. The delay increased. Traffic congestion not only wastes time and fuel, but also causes increases in stress and pollution and delays in response of emergency vehicles. So in 1986, in hours, we're just above 20 average annual commuter delay hours. In 1998, we're approaching 40. In 2006, we were up plus 40 average annual commuter delay in hours, and so on. So a way to present data, analyze, and compare results is using our plotting schemes with graphs. In section 7.3 then, we're going to be looking at statistics. A statistic is a number describing a set of data. Statistics can describe characteristics such as the spread and the center of a set of data. We first look at the minimum. The minimum of a set of numbers is the smallest number in the set. And then the maximum of a set of numbers is the largest number in a set. When a set of numbers is arranged in order from smallest to largest, the minimum is the first number listed, and the maximum is the last number listed, when arranged in order from smallest to largest. Average, or as we will learn, is also called the mean and preferred in statistics. The mean is a center point. Statistic or measure of central tendency that characterizes the data set. So again, average or mean, now as we're going to be referencing it, both calculated the same. Remember that when we have a set of data, we add first to calculate the mean, and then divide by the count. And the count is 1, 2, 3, 4, 5, 6. So we're going to add these numbers together. And get a total. Our total is 2449. We still want to divide by 6. So now 2449 divided by 6 is 408.17. So the mean of our given data set is 408.17. Be watching for the precision following the decimal point. My math lab may ask for 1 rounded to the 10th, rounded to the 100th, and so on. Average is also called the arithmetic mean, or in our case, we're going to reference it as mean. And the mean is a central point statistic or measure of central tendency that characterizes our data set. So kind of a center or a center point measure of central tendency for this data set is 408, and that looks reasonable. Keep in mind that with the mean or average, if all data items are the same, then your mean is equal to one of those data items. So if we have 408, 6 times 408 added 6 times is 2,448 divided by 6 is still 408. So if all the data items in the data set are the same, then the mean is the data item itself. Then on page 429, we're looking at the range. Oh, I guess we should calculate a maximum and a minimum, and we will come back to that. We're going to define the range. To find the range of a set of data items, subtract the smallest number, which is our minimum, from the largest number in the set, which is our maximum. So the range is equal to, we're looking at the spread of our data items, the maximum subtract the minimum. So if I have 240 plus 320, or 302, plus 280, plus 320 as my data items in this set, 1, 2, 3, 4, count. I wanted to begin to plan to calculate all of my statistics for this data set. The count, the sum, the mean, the median, the mode, the range, the max, the min. So I create this little data cheat sheet for this section. And I use it as I'm calculating statistics. And so for this problem, I'm going to jot down the count, the sum, the mean, the median, the mode, the range, the max, and the min. So I have my little cheat sheet, and I've just transferred it over to the problem at hand. So I decided that the count in this data set is 4, and the sum I'm going to determine right now, 240 plus 302 plus 280 plus 320. And I get 1,142. So now I have 1,142 divided by 4. And that equals 285.5. Now 285.5 is the result of the mean. Remember, the mean is our central tendency statistic that we calculate as the sum of the data items divided by the count. Now the median. The median we haven't defined yet in detail. And the mode we haven't defined in detail yet. But the range, we know that the range is the difference between the maximum and the minimum. So if I arrange this into order, smallest to largest, so I might have to rearrange actually sometimes. So 240 is my smallest number. Next is 280. Next is 302. And next is 320. So rearrange if necessary in order from smallest to largest. And then our range is the difference, the maximum, subtract the minimum. So 320, subtract 240, and I get 80. So I'm at, the range is 80. I had to determine in ascending order. To determine the maximum is 320 and the minimum is the smallest number, 240 in this data set. So maximum, minimum, and range. Maximum is the largest value in your data set. Minimum is your smallest value in your data set. Oftentimes it's easiest to rearrange your numbers from smallest to largest. We'll need that for further statistical calculation anyway. And the range is the difference between the maximum and the minimum. The mean, once again, to find the mean of a set of data numbers, add the numbers together first and then divide by the number of items. So add first and then divide. It's a two-step process. And the process is the same as when we were calculating average. So we know how to calculate the mean. We calculate the average. for my page. Okay, example 3. On a 4-day trip, a car was driven the following number of miles. What is the mean? We add the data items first and get 1,142, and then divide by the count to get 285.5. The car was driven a mean of 285.5 miles per day. Had the car been driven exactly 285.5 miles each day, the same total distance would have been traveled. Next, we want to find the mean if we traveled 546 miles and used 13 gallons of gas. So that's 546 miles divided by 13 gallons. .546 divided by 13 is 42. So we have 42 miles per gallon traveled. Another use for our statistics is determining grade point average. In many schools, students are assigned grade point values for grades obtained. The grade point value, or GPA, is the average of the grade point values for each credit hour taken. At this college, grade point values are assigned as follows. A equals 4 points, B equals 3 points, C equals 2 points, D equals 1 point, and F is 0 points. Meg, a student, earned the following grades for one semester. What was her grade point average? Well, she had a history class, a math class, a lit class, a French class, and a time management class. The grade she earned is listed in the number of credits for each course. In order to calculate, we're going to need the grade point value earned and the quality point earned. So I add those two columns to my table. So for a B, the grade point value is 3. For an A, the grade point value is 4. For another A, the grade point value for an A is 4. For a C, the grade point value is 2. And for a D, the grade point value is 1. Now we multiply. 3 times 3 is 9. 4 times 4 is 16. 3 times 4 is 12. 4 times 2 is 8. And 1 times 1 is 1. Now we're going to need the total credits. That's 7, 10, 14, 15. And we're going to need the total grade point quality value. That'd be 25, 37, 37 and 9 would be 46. To find the GPA, we first multiply the grade point value for each grade by the number of credits. So we did that. And then we determine the grade point values, add the number of credits taken, and add the quality points earned. And then to calculate the GPA, we're told is equal to the total quality points divided by the total credits. In our case, our total equality points are 46, and the total credits taken for the semester are 15. 46 divided by 15 is 3.07. And then just watch at My Math Lab or in your directions. That's going to be approximately 3.07. We're going to round up to 3.1. So her GPA is about 3.1. Next, we look at median as a statistical value that represents a particular data set. Another type of central point statistic is the median. Medians are useful when we wish to de-emphasize unusually extreme numbers. For example, suppose a small class scored as follows on an exam: a 56 in order, 78, an 81, an 82, and an 84. The middle score is 81, and it is called the median. Note that because of the extreme low score of 56, the average of the scores would have been 76.2. In this case, our example, the median may be more appropriate to represent the center point. So we had kind of an extreme low value, but the actual middle value, in this case, we arranged into order from smallest to largest first. It says first we have to do that, so that's kind of a step. And then from match, top, bottom, top, bottom, top, bottom, just keep working your way until you find the exact middle score. And the middle score was 81. So our median represents the middle score. And it can sometimes be more descriptive of the central point. Median, a central point statistic. Median is useful when we wish to de-emphasize unusually extreme scores in data sets. We're given 90, 91, 98, 98, 99, 106, and 870. And we're asked to find the median. Median is the middle. We have to arrange in order first, from smallest to largest, and it looks like it's already done, so we can check that off. So then we walk our way, match, 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 walk our way to the middle score, and the middle score is 98. And in this case, the median is more representative of the middle score. It kind of eliminates or de-emphasizes this out of range very high value within our data set. Sometimes we have a data set 61, 62, 63, 65, 69, and 80. We're looking for the median again. Is middle. Okay, they are arranged in order, so we can check that off. I'll take my lowest and highest and just kind of walk my way to the middle, but now it's an even data set, so I have to calculate the median as the sum of the two middle scores. And divide by 2, I'll get 64. So the middle of 63 and 65 is 64. So the median for this data set is the actual middle. It's an even data set, so when I walk my way to the middle, I'm looking at two middle scores. I'll have to find the average or the mean of those two numbers. And I come up with 64 then as the median for this data set. Was an even number in my data set. So walk my way, there's two middle numbers, calculate the mean of those two middle numbers, and that will be your median. Given 78,000, 84,000, 85,000, and 100,000. They are already in ascending order. And we're supposed to find the median. And the median is our middle number. They're in order, but as I walk my way, it's an even data set. So I have to find the mean of the two middle numbers. 84,000 plus 85,000 divided by 2. And I get 84,500. So the median for this data set that happens to have an even number of items in the data set is the mean of the two middle numbers, which is 84,500. Kind of a special case when you have an even number in your data set. I might be given 3,300, 4,000, 3,900, 3,600, 3,800, and 3,400. And I'm supposed to find the median. Well, the first thing I need to do is arrange to order if they are not in order, from smallest to largest. So my smallest number is 3,300. My next smallest is 3,400. Next smallest is 3,600. Next is 3,800. Next is 3,900. And finally 4,000. Now you will want to be very careful as you're working with these numbers and rearranging into a special order. Find some pattern that works for you. I try to check off as I'm arranging in order. So in order, now I'm looking for the median. The median I can check off, walk your way, pair, pair. Oops. I'm going to have to find the mean of the middle two numbers. So I'm going to find the mean of 3,600 plus 3,800 by dividing by 2. And I get 3,700. So the mean of the middle two numbers in this data set is 3,700, which is the mean, the middle of this data set. Median. Once a data set is listed in order, so that's criteria number 1, from smallest to largest, the median is the middle number if there is an odd number of data items. But if there's an even number of data items, the median is the number that is the average of the two middle numbers, the mean of the two middle numbers. And finally, we're looking at the mode. The mode of a set of data is the number or numbers that occur most often. So think of the mode and most often. If each number occurs the same number of times, there is no mode. Mode is the number that occurs most often within your data set. If all the numbers are the same, well, then there's no most frequent number. They're all represented. Each is the same. So we're asked to find the mode of 17, 13, 18, 17, 14, and 19. I like to arrange in order. And I always do that. That's kind of my first step when I'm working with statistics, because I need to know maximum and minimum and to calculate the median. So there's reasons why I can arrange to order and just do that right away. My smallest number is 13, next 14, next 17, there's another 17, 18, and 19. So arranged in order, I have 13, 14, 17, 17, 18, 19 in this data set. And I'm wanting to calculate the mode. The mode is the most frequently occurring value in the data set. So I'm just going to use a tally. I need to come up with some type of means to count this data. So 13 occurs once, 14 occurs once, 17 occurs once, and actually again, 18 occurs once, and 19 occurs once. My tally indicates then that 17 is the most frequently occurring number in this data set. So the mode is 17. Another example of mode, I have 5 and 5 and 11 and 11 and 13 and 13. I'm supposed to calculate the mode. Mode is most frequently occurring number. So I'll tally. I have 5 occurs once, actually it occurs twice. 11 occurs once, actually twice. 13 occurs actually twice. They're all occurring the same frequency, the same number of times. So if each occurs twice, all numbers are equally represented, so there is no mode. There's no most frequently occurring. They're all equally represented. $33, $34, $34, $34. Should go like this. 35, 36, 37, 37, 37, 38, 39, and 40. And in this case, our data set is presented in order from smallest to largest. We're supposed to calculate the mode. So with our tally, 33 occurs once, 34 occurs 3 times, 35 occurs once, 36 occurs once, 37 occurs 1, 2, 3 times, 38 occurs once, 39 occurs once, and 40 occurs once. So in my tally, I can see that 34 occurs 3 times and 37 occurs 3 times. So there are 2 modes. The modes are 34 and 37. To further distinguish, you may be asked to find the high mode and the low mode. So the high mode in this case, the number that's larger is 37, and the low mode is the mode which is smaller. So now looking at my card, I know how to determine the count of a data set, the sum, the mean, the median, the mode, the range, the maximum, and the minimum. So let's look at a data set. We have 15 grams, 19 grams, 19 grams, 14 grams, and 18 grams. That's my original data set, and the first thing I'm going to do is arrange from smallest to largest. I need to have that in order for calculating some of my other statistics. So rearrange, and let's see, I'm looking for the smallest, so that'd be 14 grams, 15 grams, 18 grams, and 19 grams and 19 grams. So I now have my data set in order, and I'm going to copy down from my crib sheet, count, sum, mean, median, mode, range, maximum, and minimum. Now I can calculate these statistics with respect to this data set. So my count is 1, 2, 3, 4, 5. The sum, I'm going to add the data set. 14 plus 15 plus 18 plus 19 plus 19, and I get 85. Now I can calculate the mean, because the mean is the sum of the data set divided by the count, which is 5. And 85 divided by 5 is 17. So the mean is 17. A central tendency point for this data set, and 17 looks like it could be representative of the central tendency of this data. The median, remember, is our middle score. So I have my in order from smallest to largest. I'm going to pair to walk to the middle score. It is an odd number in the data set, so the middle score is 18 grams. And that appears to be a realistic, meaningful central tendency score again for this data set. The mode, I'm going to build my tally. I have 14 occurs once, 15 occurs once, 18 occurs once, 19 occurs once, and again. So I do have a mode, and it's 19. The range, we know, is the difference between the maximum and the minimum. So the range is the difference in the extremes. Subtract the minimum from the maximum, and we get 5. Our maximum from our in order list is 19, and our minimum from our in order list is 14. And we've calculated the data statistics representing our data set. Okay, this data set is given to us in order: 892, 949, 964, 983, 1075, 1084, 1211, 1214, 1322, 1417, 1423, and 1521. $892, $949, $964, $983, $1,075, $1,084, 1,211, 1,214, 1,322, 1,017, 417, 1,423, and 1,521. So I have a data set. It is in order. I'm going to use my cheat sheet and calculate my data statistics for this data set. Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The mean, I need to add my data set first and divide by the count. 14,055 is the sum of my data items in my data set divided by the count, and I get 1,171.25. So the sum is 14,055, and the mean, divide the sum by the count, and I get 1,171.25. Watch at my math lab, they might say round to 2 places following the decimal point, round to 1 place following the decimal point. So just be sure that you're following those directions for your final answer completely. Now the median, remember that's our middle score. So I'm going to walk with my data, pair, 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 pair. I have an even number in my data set, so I need to calculate the mean of the two middle scores and divide by 2. 1,084 plus 1,211, and then divide by 2. That's equal to 1,147.5. So our median is 1,147.5. The mean of our middle two scores in an even data set. The mode, I'm going to build my tally and tally each occurrence. And looking at the data, I kind of remembered as I was writing it down that there is no most frequently occurring number. Each data item in the data set occurs once, so there's no emphasis on the frequency of occurring. Each are occurring equally one time, so there is no mode. No most frequently occurring data item value. The range is our maximum, and we had our list in order. So 1521, subtract the minimum. We get 629. And our maximum is the maximum in the list, which is 1,521. And the minimum is 892. So I have calculated the data statistics for this data set representing this data set. Now we just want to continue to practice working with calculating the stats for any data set. So we'll practice one more. This time I'm gleaning my statistics from a chart. More people visit the Great Smoky Mountains National Park each year than any other U.S. national park. The following bar chart shows the number of visitors in each park from 2005 to 2012. We're supposed to find the average, the median, and the mode. I'll see if I can get these numbers up a little bigger for you. So in 2005, we had 9.2 visitors, 2006, 9.3, 9.4, 9.0, 9.5, 9.5, 9.0, and in 2012, 9.7. So I'm going to collect those data values from the chart as my data set. So from the chart, I have 9.2, 9.3, 9.4, 9.0, 9.5, 9.5, 9.0, and 9.7. Now the first thing I like to do is arrange in order. So smallest number is 9.0. There's another 9.0. Next is 9.2. Next is a 9.3 and a 9.4. Next is 9.5 and another 9.5 and then a 9.7. And then I'm going to get my cheat sheet. Calculate the count. The sum. The mean. The mode. The mean, the median. And then the mode. The range. The maximum. And the minimum. Well, the count, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 is 8. The sum, we're going to add the data items in this data set. 9.2 plus 9.3 plus 9.4 plus 9.5 plus 9.0 plus 9.5 plus 9.0 plus 9.7 and get 74.6. And now I can calculate the mean. The mean is the sum divided by the count. And I get 9.33. So we're talking about the number of visitors to each national park in millions. So my mean or average is 9.33 million visitors. The median is the middle. So in my in order list, I'm just going to pair, pair, pair. It's an even list, so I need to find the median of the two middle, the mean of the two middle terms. So 9.3 plus 9.4 divided by 2. Is 9.35. So our middle is 9.35. The mode, I can do my tally. 9.0 once, 9.2, so I had 9.0 twice actually, 9.2 once, 9.3 once, 9.4 once, 9.5 once, 9.5 again, and 9.7 once. So my tally shows that I have two modes, two most frequently occurring values within my data set. So I have a mode 9.0 and 9.5. The range, we're looking at the spread, the distance between the high and the low. My in order scores, the 9.7 subtract the minimum. You get 0.7, and the maximum was 9.7 and the minimum was 9.0. So again, for this data set of visitors visiting our national parks over a number of years is represented with the data from our calculated data statistics. All right, let's take a look at our chapter summary and review, particularly just for section 7.3. Section 7.3 is all that we're covering in this chapter. So we're supposed to find the mean, the median, the mode for this set of numbers on page 465. So my set of numbers are 8, 13, 1, 4, 8, 7, and 15. And I'm going to reorder. I know I need to have my list in order at some time. So 1, 4, 7, 8, another 8, 13, and 15. So my data set is ordered from smallest to largest. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I'm going to get my statistics for my crib sheet, and I'm going to calculate all of the stats for this data set. Okay, the count, 1, 2, 3, 4, 5, 6, 7. The sum, 1 plus 4 plus 7 plus 8 plus 8 plus 13 plus 15. And I get 56. We can calculate the mean as the sum divided by the count. So 56 divided by 7 is 8. Our mean is 8, and the average is 8. That looks like a reasonable value to represent the central tendency of mean. The median is the middle score, so I have an odd set, one pair, top, bottom, top, bottom, top, bottom, and sure enough, the middle score is 8. Our mode, I can build my tally. 1 is once, 4 is once, 7 is once, 8 is once, twice actually, 13 is once, and 15 is once. So our most frequently occurring score is 8. The range is the difference of the maximum subtract the minimum. Our range is 14. And our maximum again is the largest value, which is 15, and our minimum is the smallest value. So again, we've calculated our data statistics for this data set. Okay, and then on page 468, we're supposed to calculate the grade point average. Find the grade point average for one semester given the following grades. Assume the grade point values are 4 for an A, 3 for a B, and so on. Round to the nearest tenth. So we have our chart. Math, English, computer science, Spanish, and college skills were taken by this student. For math, we got an A. It was 5 credits. So let's continue our table for the grade point value and the quality points that were earned. So an A is worth 4 as a value, a B is worth 3, a C is worth 2, a B is worth 3, and a B is worth 3. We're going to multiply. Five times 4 is 20. 3 times 3 is 9. 2 times 4 is 8. 3 times 3 is 9. And 3 times 1 is 3. We need the total number of credits. It's 8, 12, 15, 16 total credits. And we need the total point quality earned. And that's 29, 37, 46, 49. And we calculate our GPA as total quality points earned over total credits. The total quality points earned were 49. The total credits taken this semester were 16. So 49 divided by 16 is 3.06. And then our directions say round to the nearest tenth. So before I circle my final answer, I'm going to double check. It should be rounded to the nearest tenth. So 3 point, I want to round, peak next door, 5 or greater, I'm going to add 1. So the GPA is 3.1. All right, once again, return to D2L Brightspace for all details regarding homework, assignments, tests, and due dates. Remember, we're focusing on section 7.3. Section 7.3 is your topic for your Chapter 7 test. All right, thank you very much.